Equation of lines and linear models. So probably talked about different forms of a line. We have a slope-intercept form, y equals mx plus b. Right, we have the standard form, ax plus by equals c. And now we're going to have point slope form. Now the benefit of point slope form is the best way to make equation. I call it the equation maker. Slope-intercept form is the best for graphing. Standard form is the best for, I guess, intercepts or something. But point slope form is when you want to make an equation, we're going to use point slope form. If you look at it, it should look familiar. Those values in point slope form, that's because it comes from the slope. If you remember our slope equation, y2 minus y1 over x2 minus x1. If you multiply both sides by the denominator, x2 minus x1, these cancel out and you get that guy. Where x2 we just label x, and y2 we just label y. But that's where it comes from. It comes from a slope equation. Multiply both sides by the denominator. But anyway, that's point slope form. It's what we use to make equations. So let's do an example. Find the slope-intercept form of the line shown. So I'm going to write down my y minus y1 equals m x minus x1, my point slope form. When you do point slope form, you need two things. You need a point, hence the name, and you need a slope. Now in this case, I have 2 points and no slope, so we got to find the slope first. Now remember, two ways to do a slope. You can do a slope equation right here, or you can do rise over run. I'm going to do that here because it looks fairly straightforward. Right, so you go from left to right, from 7 all the way down to 3. So we went down 4, and then we went over 2. So my slope here is going to be negative 4 over 2, which is negative 2. Again, if you prefer, you could find the slope by finding your 2 points and doing y2 minus y1 over x2 minus x1. So my slope here is negative 2. My point, I have 2 points. It doesn't matter which one you pick. Either one works. I'll choose 3, 3. So I'm going to have y minus, this is x, y1 is 3 times negative 2, x1 is 3. Right, so I'm plugging negative 2 here and 3 into there. And then this one they do want a slope-intercept form, so I can do like y by itself. So let's distribute. Y minus 3 equals negative 2x plus 6 plus 3 to both sides. You get y equals negative 2x plus 9. And there's our equation. Now this will show you that it doesn't matter which point you pick. Let me do the same thing with 1, 7. So in this case, I'll have y minus 7 equals negative 2, x minus 1, distribute negative, y minus 7 equals negative 2x plus 2, add the 7 over, and you get y equals negative 2x plus 9. So it doesn't matter which point you pick. It works the same either way. Example 2, the table in the margin lists some points found on line y equals mx plus b. Find the slope-intercept form of the equation of line. So again, we want to find the equation of a line. We're going to use our favorite formula for that, y minus y1 equals m x minus x1. Since all these points are found on the line, you can pick any two. I like to work smarter, not harder, so I'm going to pick the easiest two, which are the top two here. Select this group right there. We'll say that's x1, y1. And then let me give myself a little space so it looks nicer. We'll say this is x2, y2. Again, it does not matter which two you use. It's all going to be the same because they're all points on the line. Now, just like before, we got to find our slope first. So this time I don't have a graph. I'm just going to do y2 minus y1 over x2 minus x1. And just plug it in the way we have it. 7, 4, 3, and 2. And I get 4 over 2, so just 2. There we go. And then again, I need x1, y1. You could use either one, doesn't matter. I'll just use x1, y1 so I don't get confused. So 2 and 3. Y minus 3 equals 2 times x minus 2. Distribute. Y minus 3 equals 2x minus 4. Again, I'm only doing this because it says specifically put in slope-intercept form. No, I'm going to just leave it like this. But they want slope-intercept form, so I'm going to simplify it. And I get this. And there's our answer. Okay. Standard form of a line, you can see here, is where the x and y are on the same side. So ax plus by equals c. X and y are on the same side. Now, some books want you to make the a negative or don't like to have fractions. It shouldn't matter. This is standard form. It doesn't matter if a is negative or not. So how do we graph an equation in standard form? Lots of ways to do it. Probably the easiest way for most standard forms is just to find x and y intercept. So that's what we're going to do here first. So let's find the x-intercept. which is where you set y equal to 0, also known as the 0 of the equation. Right, so we're just going to set y equal to 0, so 3 times x plus 2 times 0 equals 6, 3x equals 6, x equals 2. So remember that is the point 2, 0. And let's find the y-intercept. Set x equal to 0. So 3 times 0 plus 2y equals 6, 2y equals 6, y equals 3. So that's the point 0, 3. And if you have x y-intercept, all you have to do is plot those 2 points. Right there, so my x-intercept. 1, 2, 3 is my y-intercept. And connect them. So that's one way to do it. Another way to do it, I'm going to show you right now with the graphing on a calculator. So let's talk about that, and then I'll talk about the other way of doing it. So here's my calculator, turn it on. So remember, I got to go to y equals the graph on my calculator. First thing you should notice though, they all have y, they have y equals, exactly what the button says. So if you have something in standard form, and you want to graph on the calculator, you have to move it to slope-intercept form. It's the only way the calculator does it. So if you want to graph on your calculator, move to slope-intercept form, which is the other way of graphing something in standard form. Just move to slope-intercept form, and then graph it using slope and the y-intercept. So in case I was doing it here, I get the y by itself for the slope-intercept form, so let's subtract 3x from both sides. So 2y equals negative 3x plus 6. Divide everything by 2. Everything gets divided by 2. Plus 3. So we get that equation. I didn't realize that calculator was in front of that. There you go. So I did all that work, and you get that equation. Anyway, now I can plot it. So negative 3/2 times x plus 3. Hit graph. It's in my standard form, and you get an equation. Looks like that. Right, same thing as here. But again, we knew that. I could do graph this the way it was. Go to plus 3, then the slope up down 3 over 2. Exact same graph. So that's how you do your calculator. If you're going to do something in your calculator, you have to get the y by itself. If you can do it by hand in standard form, you could do x, y intercept. I personally probably still prefer to do slope intercept. Just move to slope intercept and graph it. Next one. Write the slope intercept form of the line that passes through the given point. Do not use the calculator. So 2 examples here. So you want the slope intercept form of the line like this. So again, anytime you want an equation of line, easiest way mostly to do it is by doing y minus y1 equals m x minus x1. You have a point, that's your x1, y1, and you have a slope, that's your slope. So you get y minus 1 equals negative 0.5 or 1/2 x plus 8. Again, they want a slope-intercept form, so I would solve for y by itself. So negative 1/2 x minus 4, and then add the 1 over. That's where that 1 came from, I added it over. So y equals negative 1/2 x minus 3. So something to that effect. Now this one, now you have a graph. When you have a graph, it's actually easiest to write an equation using slope-intercept form. You could still do point slope form if you want. Find a slope, find a point, plug it in. But if you actually have the graph with the y-intercept specifically, then you can just do slope-intercept form. All you need is a slope and a y-intercept. And we have the y-intercept right there. Looks like it's going by 4s, right? 4, 8, negative 4, 8. So this looks like negative 4. And all I gotta do is find my slope. So pick 2 points. That cross nicely. Let's look here and here. Looks like I went down 8 and I went across 8. So my slope here is going to be, remember it's 8 because it's going by, you could say 2 and 2, but it's going by 8. Rise over run, so I went down and then I ran 8, so negative 1. I remember, so this is my rise, in this case I fell 8. Slope is also known as rise over run. So I fell 8 and I ran 8, so negative 1. That's where that slope came from. Anyway, that would be my answer. So if you have a line, it's actually easier to do in standard form. Because again, you can still do it this way. Y minus y1 equals m x minus x1. Plug in any point on this line into your x1, y1, and plug in your slope. It'll work out the same way. Find the slope-intercept form of an equation satisfying this. So you have 2 points. And you want to find the slope-intercept form. Again, if I'm doing this, I would do this. And all we have to do is find the slope and a point. You have 2 points, so make any one you want, x1, y1, x2, y2, and just find the slope. Again, if I have 2 points, it's like when we had the table, I would find the slope the old-fashioned way. y2 minus y1 over x2 minus x1. So I get 2 minus 4 over negative 3 minus negative 5. I just substituting in the way I see it. y2 is 2, y1 is 4, x2 is negative 3, x1 is negative 5. Simplify, I get negative 2. Double negative makes this a positive, so it's negative 3 plus 5, which makes it positive 2, which makes my slope negative 1. And again, you can use any of these points, it doesn't matter. I'm to keep it standard, I'll use the one I labeled y1 and y2. So I get y minus 4 equals negative 1 x plus 5. And again, they wanted slope-intercept form. They don't stop with that. Again, you don't always have to put it, just whatever they ask. In this case, they've been asking to put slope-intercept form a lot. So we did get that. Okay. Parallel and perpendicular lines. Two lines are parallel if they do not intersect. So in a graph, two lines are parallel. They do not intersect. And that only happens when you have the same slope. So two lines are parallel when they have the exact same slope. So parallel lines have the exact same slope. We're going to use that knowledge set to write some equations. Find the equation of a line that passes through the point 3,5 and it's parallel to the line with the equation of this. Graph both lines in standard view window. We're not going to do the graphing part, just to save some time. So, right, I want to find the equation of a line. And when I hear those words, I go y minus y1 equals m x minus x1. So as always, we need a point and we need a slope. Now, they gave us a point already. There's my x1 and y1, so 3 and 5. All I have to do is find the slope. Now, they do tell us, so only thing they tell us is that it's parallel to this guy. Parallel to this line here. So remember, parallel means same slope. So we got to find the slope of this line, and then it's going to be the exact same slope, so just plug it in for m here. Now watch out, the slope here is not 2. Remember, if you want to find a slope, you have to put in slope-intercept form. So if you have a line and you're trying to find the slope, you have to put in slope-intercept form. That's the good thing about slope-intercept form. It's good for a couple of things. It's good to graph, and it's also good to find the y-intercept and the slope. So if you ever need to find a y-intercept or slope, just get y by itself, having a slope-intercept form. So we gotta get y by itself here. Let's subtract 2x from both sides. I get 5y equals negative 2x plus 4, and then we divide by 5. Divide everything by 5. So y equals negative 2x over 5 plus 4/5. Now again, all I need is a slope here, and again, another thing you want to watch out, my slope here is not negative 2x over 5, it's just a number, it's just a coefficient, it's negative 2 over 5 is my slope. So that's what I'm going to plug here. So my answer is going to be this. Now look, for once they didn't say put in a slope-intercept form, so I can just leave it. There's my answer. Right, so when you know two things are parallel, you just have to know they have the same slope. So plug into our formula, so point slope form, get your point, and then find the slope. When you find a slope from a line, it has to be in slope-intercept form. So you have to get y by itself first, and then you can find your slope. How about perpendicular lines? Perpendicular lines have negative reciprocal slopes. So if two lines are perpendicular, then their slopes are negative reciprocals. Over here they say the product is 1. It's the same thing, but negative reciprocal works better for me. So what does that mean? For example, so if we say m1 is perpendicular to m2, then if I tell you m1 is equal to 3/5, that means m2 is you negate it, so you change the sign and you flip it. So it becomes negative 5/3. So these two slopes will be perpendicular. And yes, you can multiply them and you get the product of 1. Again, in my head, negative reciprocal works better. There's a note here. If I give you a perpendicular line, I'm like, hey, x equals 3, what's perpendicular to that? Well, that's a horizontal line. So the thing that's perpendicular to a horizontal line is a vertical line. So it would have to be like y equals 2 or something. It has to be a horizontal or vertical lines are perpendicular to each other. the number here doesn't really matter. It's just the fact that if you have a vertical line, the perpendicular to horizontal and vice versa. Anyway, let's do an example again. Find the equation of a line that passes through 0.35 and is perpendicular to this equation. So again, we're finding the equation of a line. So we're going to do y minus y1, or point slope form. We have our point, or x1, y1. Makes that part easy. And now it says it's perpendicular to the equation with this line. So we do the same thing we did before. We have this equation. We got let's find the slope. And we got to put in a slope-intercept form to find that. You got to plug in y equals mx plus b to find it. So I'm going to get 5y equals negative 2x plus 4. Just subtract the 2x from both sides. Then we're going to divide everything by 5. And I get y equals negative 2x over 5 plus 4/5. Now again, the slope I need is perpendicular to that. So my slope, my perpendicular slope, is you flip it and change the sign. So it goes a positive 5 over 2. Right? It was negative, now it goes positive, now it's 5 over 2. So you flip it. And there's my equation. Again, another one where it didn't say put in the slope-intercept form, so we just leave it like this and we are good. So there we go. Linear models and regression. So to make a linear model or regression, we need a scatter diagram or a scatter plot. That's when you get your data and you plot it. And what you do with that plot is you can make a line out of it, like trying to fit the best data, and then with that line you can make an equation known as a linear model or a regression equation. So that's what we're going to do here. We're going to plot data. We're going to use that data to try to make a line that fits it the best, like you see here. And then once we have a line, we can make an equation. So first we're going to do it here. Projections for the net Medicare spending in billions of dollars are shown in the table of margins. Make a scatter diagram of the data, let x equal 0, and correspond to 2018. So this is basically going to be 0, 1, 2, 3, 4, 5, since we don't want to like go all the way up to 2018. And so on. Are the data approximately linear? So first we got to plot it. Now, I'm not going to do it the greatest, but let's say it's 0, 1, 2, 3, 4, 5. Now, let's go. We're going all the way to 890. I'm just going to do it. I'm going to count by 200s. 200, 400, 600, 800, and 1,000. Again, it's going to be a rough estimate. It's not perfect at any means, as you can tell. So my first data plot is going to be 5 cents. By the way, we should label our axes. This is x, which is years, and y, which is cost. So I know what we're talking about. So my first data point is 0 and 57, 5,574. So that's around here. Estimate. And then we have 1 and 642. Ish, so around there. Then we have 2 and 688. Then we have 3 and 738. And then we have 4 and 833. And then we have 5 and 852. So it should be about the same spot. So I get a graph that looks like this. Again, not perfect, the scatter plot. No one's had the right, and no one's had like the exact same answers as everybody else. So you have something that looks kind of like that, roughly. Is the data linear? Yeah, it's kind of linear. It looks kind of like a straight line, right? There's a little curve to mine, but mostly you can make that a straight line. So I'll say yes. Find a linear function that models the data, graph f, and the data in the same view window, and interpret the slope. Okay, so he wants to graph this. Well, he wants to come with a linear model. First thing we do by hand. And the way we do that is we try to draw a line of best fit. Now, it doesn't have to be perfect. We're just trying to draw a line that fits most of the data points. You're not trying to hit the data points. You're just trying to kind of be in the middle of all of them. So that's my best estimate of line of best fit. And then we come with an equation. How we write an equation? The same way we always do. Y minus y1 equals mx minus x1. Now, we normally do this, you have a big old grid. So you have points that cross nicely. I don't have that. I do have this point that crosses kind of nicely. That looks like the point 0 and 600. And I'm going to use this point right here. That's the best point I got. That's 2 and 688. So I'm going to use those 2 points to come up with my equation. We're going to have one be x1, y1. And x2, y2. So first I gotta find my slope like always. So I'm just gonna do y2 minus y1 over x2 minus x1. So in this case, my y2 is 688, my y1 is 600, and my x2 is 2, my 1 is 0. So I'm going to get 88 over 2, or 44. So there's my slope, 44. And then I need to substitute in a point. Again, you have 2 points. Well, don't make it difficult. Just plug in x1, y1. So now 0 and 600. So we get this if we simplify it. And generally we want to put in slope-intercept form. So let's distribute. When we're doing linear regressions, generally we want a slope-intercept form. And add the 600. So I get y equals 44x plus 600. So that's my linear regression model, or my model that models the data. Then I want to graph f and the data in the same view window, interpret the slope of m. So let's do that first. Let's interpret the slope of m. I said this before, but the slope, you just gotta look at your unit. So our slope is 44, I'll put 44 over 1. What are my units? Remember, slope is the change in y over the change of x. So my y is on top, which is cost. And my x is on the bottom, so year. So I have positive 44 costs per year. So what does that mean? That means on average the cost is rising about 44 billions of dollars, $44 billion per year. That's what that means. That cost is increasing. It's increasing because it's a positive 44. If it was negative, cost would be decreasing. On average, 44 billion per year. That's how you interpret slope. It's always just y over x. What's your y? What's your x? Put the line there. That's per. So in this case, 44 per year. So that's how we get that. Use your model to. We're gonna skip the graphing part because I'm gonna do it for the next one. Use your model to predict Medicare spending in 2024. So look at my thing. Look at our table here, right? 2024 would have been the next year, so it'd be year 6. So I want to try to estimate the cost in year 6. All I have to do is substitute 6 into my equation. So cost in year 2024, sorry. All we're going to do is substitute in x equals 6. So I get y equals 44 times 6 plus 600. 44 times 6 is 264 plus 600. I'd get 864. So that would be the estimated cost in billions in the year 2024. So that's how you do a linear regression by hand, right? You plot your plot your data onto a graph. You make a line that try to do a line of best fit by yourself, and then once you have the line of best fit, it's just like what we've been doing earlier. Find 2 points, find the slope of the 2 points, like I did here, plug it all into your equation, and then simplify. Now let's talk about how to do that with the calculator. We're gonna do the exact same thing, but now we're gonna use our calculator to do it. So let me bring up my calculator. Let me turn it on. I know it looks on. It's not on. It's not on. So we're gonna get this. So we have that. Now, first thing, let's put this data into our calculator. So the way we do that is we go to stat, we go to edit, and we're just gonna type it in. So remember, it's 0, 1, 2. We're gonna follow the same idea we did last time. So 0, 1, 2, 3, 4, 5. Then we're gonna go to L2 and we're gonna type in the cost here. I'm gonna do this off camera. And I get that. Again, I did it off camera. If you want to pause, catch up, feel free to. I just didn't feel like wasting your time having me plug stuff in. Anyway, so there's my data. My data is plugged into the calculator. So next, if we want to find a linear regression line, we're gonna get out of here. We're gonna go to stat, move over to calculate. So I should write some of this down before I forget. So data. If you want to enter data, you just want to hit stat and then edit. right? You can tap in, you can do for L1 and L2. If you want to come with a least squared regression line, we're going to go stat. We're going to move over to calculate. You can see the calculator, how, let me get back out of here. When you go to stat, wrong one. When you go to stat, right, you have edit, calculate, and test. We're going to go to calculate, and we're going to go down here to linear regression, number 4. And then it asks you, is your X your L1? Yes, my X is L1. Is your Y your L2? Yes, it is. Frequency list, you only have that if you have a frequency. If it literally says frequency, and most of the time that'll be L2. If you have a frequency, it'll be L2. If we don't have it, so we're gonna leave it blank. Store requests. Store regression equation. Sorry, store regression equation is what that stands for. That's if you want to store it. If you want to plug it into your Y1. Now it's a little fancy. I'll go back to that. We'll do that in a second. But for now, I'm just gonna leave it blank. Then we go to calculate, and that's our regression equation. So I tell you right there, your A, your slope is 57.51, your y-intercept is 577. So I'm going to write that down. We'll go round to nearest tenth. So 5x plus 577.4. That's the that's the calculator got for the regression equation. Now look at the one we got up here, right? It's close, not perfect, because we're doing it by hand. 44x plus 600. So our slope was a little off. There's no good place to put that calculator. I mean, our slope was not very good, but our y-intercept wasn't bad, 577, 600. So that's all the work. But if you want to visually represent this, like the scatter plot, we haven't talked about that. Let's visually represent everything. So let's go back to the scatter plot. Right, our data's stat edit. There's our data. If you want to graph it, we have to turn on our stat plot. So I'm gonna go first. I'm gonna go to y equals, make sure it's empty, because we're gonna stuff earlier, right? So I'm going to go to stat plot, second here. So the second stat plot, and you got to turn it on. So hit enter. Now the very first choice here is on or off. So I'm going to hit it on. Then the second choice here is what type of plot do you want to graph? Now we're doing scatter plots. So that's the very first one. So we're going to leave that the way it is. And you scroll down. Do you want your X to be L1? Yes. You want your Y to be L2? Yes. What type of mark do you want? I mean, it doesn't really matter. I'm going to keep it the way it is. And then hit graph, and you don't see a thing. Why not? Because our window is off, right? I have 0, 1, 2, 3, 4, 5, but look at the Y values. It's all the way up there. So if I'm going to fix it by hand, I'm going to go window. My lowest X is 0. I like to give myself a buffer though, so -2. My highest X is 5. 10's fine. We're going to count by ones. Look at my Y min here. I mean, it's -10, it's fine. You could go to 0 if you want, but how high do I got to go? All the way up to like 852. So I'm going to give myself a buffer like 900. Now when I hit graph, I should see my scatter plot. Now I want to see how close our regression line hits to it. Now before, let's do the one I did earlier. Right, so before I hit, what was our regression line? Let's type that one in first. So that's y equals 44x. I'm going to go to y equals. I'm going to do it under y2, and I'll explain to you in a second. Let's do y1. We're pro. I'm going to hit 44x, remember our variable button, plus 600. I'm going to hit graph. And you can see how close my data went to that. How close my line hit that data. Pretty good. I'm happy about that. And then I'm gonna go white. And then if you want to put the one the calculator found out, how do we do that? So let's get out of here. Let's go stat. Let's go calculate. Go back to linear regression. And then that thing I left blank before, the store regression equation, I'm not gonna leave that blank anymore. So what I'm gonna do here is I'm gonna type in y1 or y2 into this, wherever I want to store it. Now the easiest way to do that is to press alpha and then F4. And that brings up all the y's you want to type in there. So I want to type in, let's do y2. Because it already has to be in y1. So that what this is going to do, it's going to figure out the line, and then it's going to store it in y2. So let's go down to calculate. Right, calculate the same thing we did before. If I go to y equals now, look what they did for y2. They typed in our equation. So if I hit graph, the first graph you see is the one I did by hand, and the second graph you see is the one the calculator did. You can see the difference there. Let me delete mine so you can see the second one better. Look how close it hits. I think that's a better regression. Anyway, so that's how you do regression. That's how you store in your calculator. That's how you view it if you want to view it. there's one more thing I talk about with regressions, and that's the correlation coefficient. That's R here. R is how close does your data fit in a line? Like, is it really close together like it does here? Or is your data kind of like jumbled up like this, it's a little separated? Or is it like all over the place? So the general rule, if you had correlation coefficient R, which is like close to 0, it's all over the place. If your R is positive, then it's a positive correlation, like you see here. If your R is negative, it's a negative correlation. And if your R is a perfect 1 or negative 1, that means like it's perfect. It's an exact fit. Now, how do you get this R? How do you get this correlation coefficient that lets you know if your data is positive or negative? Now, in the calculator, for some reason, it's always set to default off. You have to turn it on. And the way you turn it on is you go to mode, you go toward the bottom, and there's a thing that's called stat diagnostics. You have to turn it on. Once you turn it on, it's going to stay on unless you reset the calculator, but you turn it on. By the way, it's only for TI-84s or above. If you have a TI-83, it doesn't do this. This is why I don't put it on the Quizzer test. You know, it's an easy idea. Anyway, so now it's on. What does that mean? Well, if you go back to your linear regression, right, I'm going to select the one we did earlier, and hit enter, they give you this extra data here. So you can see your R right there. Remember, that R just lets me know, is it positive, is it negative? This is a positive R. We have a positive correlation because it's going up. And it's actually really strong. It's almost a 1. It's almost a perfect correlation. Anyway, that's what R is. That's what it tells you. It tells you if your data is, how close your data is rated, and then if it's positive or negative.